All right, good afternoon, everyone. I appreciate you coming out. We're going to get started. So I've got some good news and I've got some bad news. Let's start with the bad news and then we'll get to the good news. The bad news is that there are well over 355 million children around the world who are living in poverty. Poverty damages children's growth, it impacts their learning and development, and it prevents them from reaching their true potential. But the good news is that Compassion International is here, and their role is to break those generational bands of poverty. They work with children to meet their needs currently, as well as looking to their future needs. My name is Mike George. I'm a Principal Solutions Architect with AWS, and I work with organizations, with nonprofit organizations like Compassion to help them better fulfill their mission. And I'm joined today by a couple of folks. I'm joined by Jeff Collins, who's a Senior Director of Architecture, Data and Analytics and Platforms from Compassion. And I'm joined by Alex Nelson, who is a Senior Solutions Architect from Compassion International. Jeff and Alex are both working to change Compassion into a data-driven organization so that they can better protect the children that they care for and better help Compassion meet its mission objectives. During today's talk, you're going to learn about how Compassion is evolving its organization to become data-driven. Now, you can help out too. You can be part of Compassion's mission today. You can go to the Compassion website, you can sponsor a child, or you can donate to many of the different causes that they support. Just to give you a sense for that, Compassion currently serves 2.3 million children across 29 different countries. In the last year, they've helped provide 1.5 million medical interventions. They provided 10.6 million family food packs, 7.6 million hygiene kits, and they've donated $16 million to disaster relief efforts. The folks at Compassion International have found that children in their program are 80% more likely to graduate from college and 75% more likely to become leaders in their communities. This breaks those generational bands of poverty. But you can't do this without data. And so I want to turn the time over to Jeff to talk about how they are unleashing compassion. Jeff?
Thanks, Mike. So I'm not going to say anything for a second that you need to take a note on. So I'd just like you to look at the screen and look at those little faces on the right side of the screen. Those are the future leaders of their families, of their communities, of their nations. And at Compassion, we focus on those faces of the kids, and we're a religious organization, how the Lord sees the future potential of those kids. Releasing them from poverty involves technology, but the focus isn't on technology. And so every minute that we work through frontline churches around the world, every minute that we can keep those frontline church staff focused on the faces of the kids rather than doing reports in technology, or every minute that we can protect children with data from people who might try to use our organization to attack kids, get a relationship with them, molest them in some way, is time that our staff can focus on the kids. And so we're going to talk about two things. First, I'm going to talk about how we needed to go about raising trust in shared data. And then Alex, my colleague, is going to come up and then talk about one use of that data, which is protecting the children with it. So we set out 3 big strategic destinations for Compassion, and I'm going to talk through each one of these. The first was we needed to move toward a more platform thinking mindset. We are a 70-plus-year-old organization, and as you can imagine, with a 70-plus-year-old organization, there is a lot of data because there have been a lot of people making great decisions from their perspective over years and years that is not necessarily compatible with a modern method of data and analytics. And so to start getting people how to think together about a platform was the first major destination that we needed to set out. I'm going to talk about 2 other topics then, after I talk a little bit more about the platform. I'm going to talk about a data fabric design pattern that then Mike is going to expand upon a little bit more after Alex and I talk. And then the other thing, and this may apply to your organizations too, you need people to start thinking with their hands and trying things. You need to get the technology into hands so that you overcome the fear and so that you start to learn how to come alongside people to allow them to focus on the faces rather than the technology. So that you can put your experts, and we've got a bunch of technology experts up here in the front row from Compassion, how to get the experts next to the people to support them and learn what they're trying to accomplish. So I'm going to talk first about how to move about thinking to the platform. And I use this picture up on the screen as an illustration of we behind the scenes are focused on making sure that we've got a rock solid base to that pyramid, that blue part of this picture. That doesn't mean that different people from different parts of the organization or our supporters or our past beneficiaries, our frontline churches, need to have a view of those systems that is varied, and yet those systems have to be solid, and because we're a donor-supported ministry, we need to steward resources well. And so they need to be consistent across, we work through 8,500 frontline churches in 29 different nations. We've got about 88 different languages and dialects that we deal in at Compassion. And so this picture of this flower is one metaphor that we've used, that when a flower opens, different creatures might come to that flower for different purposes and take away from that flower what they need. It's similar to how we think of these different users interacting with the platform. I tell you that not because I think this audience doesn't know how to interact with the platform, but to encourage you that when you're a multinational organization thinking through how to explain the capabilities that you, the technologist, are trying to deliver is an important part of a strategy to move your large organization forward. Now, I'm going to use one example, and we call it program cycle adoption. This example is really important to Compassion because, as Mike explained, we measure our impact on those children. And so in order to start collecting, we're a holistic child development program. And so to start collecting data that we can then provide to supporters and our own program officials, we knew that we needed to set about getting a methodology for come alongside those frontline churches to collect the data, as well as then being able to understand what you do about the data once you collect it. And so getting those data collections in place involved setting up data pipelines, making sure that we could collect data in bandwidth challenged areas, keeping that data on tablets, and then pouring it back into data warehouses and through AWS systems. And so thinking through every aspect of that capability so that then we can get that data, we can get insights into the data, but then most importantly, we can feed those visualizations back to the elders and pastors and staff at the churches so that they can make decisions about data-informed decisions about what would be the best intervention to help this set of children at this time in this place. The other benefit of platform thinking then is there on that bottom slide. You benefit from common branding, having a user experience that you can walk people through, training, and then increasingly important, and if you're a global organization, you know that different countries have different rules about data. And so a platform can enable you to govern your data wherever it resides in an appropriate way for that nation's laws. So then once you have an organization thinking about the platform, Part of making sure that you've got a very stable architectural pattern for us was to put a data fabric pattern in place. What that means is that data doesn't need to be replicated, but instead can be accessed from multiple areas of the ministry through a data model, as you see there at the top, that gives us a consistent way for us to understand and agree on what the different data fields in the vast number of systems that we're dealing with mean, and then share that data. And so I'm going to talk a little bit about the data fabric. You can see there's an abstraction layer that involves the data model along with what we call the compassion outcomes framework, which is how different variables or data fields interact with each other, so that as we're collecting the data, we can understand, like for example, that allows us to understand BMI in different ways and the relationship between the different variables that we're collecting on that. And then finally a data catalog that allows people to discover across the enterprise what data is available, what decisions data stewards have made about the data that's available. And then there's a storage layer that enables people to access that and serve that up at whatever latency is required. And you're going to hear a little bit more about that as Alex talks. What's important for you strategically as you're moving to whether it's a data fabric pattern or another pattern that your organization has decided to implement is that you have to decide whether you're going to pay down all the tech debt on all the work that has been done in the past, or whether you're going to focus on the future. At Compassion, we decided that we would insist that new things integrate into this new pattern, and old things we would decide on a case-by-case basis as we made updates whether or not it needed to integrate into the new pattern. I already mentioned a few of those bullets then that I've provided here for you about the benefits of a data fabric pattern. What I'd encourage you is that you trying to get governance into place, and at our ministry at least, there wasn't really a great method for data governance across the entire global enterprise. So thinking first about those cross-domain data interactions and what's important rather than trying to decide every data field in every system, getting your arms around what you should sweat and what you need to worry about later is really important as you get data governance into place. And then as that metadata, you can start to collect the metadata and start to understand what are people actually using. And then those are other areas that you want to make sure you've got the governance right. So I've talked about two big strategic directions. I first talked about the getting people thinking about platforms for data and ability to use data. Then I've talked about one of the stable parts of a platform, which was the data fabric. And now I'm going to talk about that third big strategic area, which is how do you get people to try things, to get their hands dirty, to start to learn, because study after study shows that the best way to learn is through project-based learning. And so at Compassion, we used two methods, which we have since combined into one. We do both AI hackathons and what we call Ignite events. And these are, for a 2-week sprint each quarter, we allow teams to focus on whatever passions they have, whatever ideas they think that might be good for focusing on kids, or learning. A new capability might have come out that they haven't had time in the hurly-burly of all the sprints during a quarter to focus on, and so they want to set aside to do that learning. So we call those Ignite events, and then we encourage people to also think of improving AI capabilities. I'm going to talk to you about a few examples that have come out then of those AI hackathons. I think that it's really important for you as you're walking into this strategic capability of getting people to think with their hands and learn things, is that there needs to be a really low barrier for entry. But you also need to try to point people in directions of thinking what your overall organization, or in our case, our ministry, needs. And so what you see there in objectives, those objectives are kind of areas that we want people to be focused on in their use of AI. And then we really leave it up to them to think, to form their own teams as we're leading into one of these Ignite events. And so I'm just going to talk through these 4 slides very briefly, kind of as examples of how people have set those broad business objectives to meet through what they've tried during the Ignite events. So the one in the middle there is about stewardship communications. So using generative AI to understand what those 8,500 frontline churches are asking about through grant requests, getting that into a translated and into a better format, so that it's more ready, not fully ready, but more ready for communicating with potential donors. We had a team who came up with an idea, and again, we're a holistic child development organization. A team came up with an idea of, could we help the children improve their prayers, not only for the children, but also for the frontline staff, by being able to communicate more directly with staff in other parts of the world about what their prayer needs are. So this prayer partner app is what came out of that 2-week sprint in that regard. We're of course interested in how we improve our own coding, and so a team set out to see how well Sourcegraph Cody could start to improve and speed up and find vulnerabilities and improve our backend capabilities. And then finally, directly focused again on those faces, a team came up with the idea that perhaps we could look at the letters that children are writing to their sponsors, and through an aggregation and machine learning of the information in those letters, we could start to suggest things that frontline church might need that would kind of indicate areas of intervention or areas of additional investment. And so getting from the kids and what they're writing back to their sponsors, ideas for how we can steward our resources well to meet those needs out there was one of the other ideas. Other ideas have been great in terms of potentially using AI to look at the pictures that kids are drawing back to their sponsors to start to discover potential mental health challenges that could happen, all the way to understanding frontline staff and their needs through dialogue. So I've given you kind of several examples then of how we've encouraged our staff to try things. And so we've moved from this model of, hey, let's get people thinking about the platform to become that more data-driven organization. Let's give people a trusted way of better trusting the data so that they can stop relying on spreadsheets. Not that they don't still rely on spreadsheets, but give them easy mechanisms to stop that behavior and move to a data fabric behavior. And then giving people a chance to set aside time to invest in their own passions. And so I'm going to hand it over to my colleague, Alex, who's going to talk a little bit more about how we're protecting children with some of the data.
Perfect. All right, thanks, Jeff. So now we're going to take kind of a slightly deeper dive into some of the technology that we've employed to help protect the children in our care. So what I'm going to talk to you about is a project that actually came out of one of those Ignite/Passion projects. And where it came from is, as Jeff talked about before, and as Mike talked as well, we use a sponsorship model. So we have sponsors and donors that come in and want to sponsor a child and help lift them out of poverty. Well, as part of that process, we collect address information. And so during one of these passion projects, one of our employees said, hey, what would happen if we found a list of known offenders and compared those addresses against our supporters? That might be a way that we could help prevent somebody from getting access to these children and potentially causing them harm. And so out of that came the Patch Project. So this is the global unveiling of Patch outside of Compassion. So you all are getting the preview here. Patch is actually, it went into production earlier this year. It is still under continuous development, and we'll kind of explore some of that as we go along here. But if you attended Werner's keynote address this morning, or you watched it online, however you got to it, one of the things he talked about is that oftentimes simplicity hides complexity underneath the hood. And so this ideogram here for the Patch Project, it looks relatively simple from this perspective. But if we dive into it, it's actually fairly complex. It represents everything from strengthening vulnerability to the fact that Christ is the core and the center of our mission, to the protection of children, that children are the aim and the goal of our efforts. And on the far right there, you see the capital P, which is protection of the children. And so that's what this whole project is about. And so I thought Werner's talk this morning was a great segue into the complexity behind it. And so oftentimes the things that we think are simple, checking addresses, turn out to sometimes be a little more complex than we might think from the beginning. Before we dive into the actual details, one of the things I wanted to get out of the way is on the screen, you'll see the Webster's definition for fuzzy logic. And that's important in this case because really when we're talking about fuzzy logic, we're talking about that we don't have single binary choices. It's not a 1 or a 0, it's not true or false, it's somewhere in between. And so oftentimes if you're dealing with AI or ML, you're dealing with probabilities. And so this is quite similar. And you'll see where it fits in as we move into the actual Patch application here. So like I said, we started out with doing person screening. We're going to do addresses. Now, anyone who's worked with addresses for any length of time knows addresses are messy. People fat finger them. I do it all the time. I mistype my own address on a regular basis, and then I wonder why it doesn't, my products don't ship to me in the right place. And so as part of this, one of the things we decided to do is, okay, we're going to go and standardize all of our addresses. We're going to go through and create a standardized list of all of our supporters' addresses. We're going to go through this offender list. We'll standardize all those addresses. And then as we get new addresses in, we'll cross-check between these things. And so on the left-hand side there, you'll see a neighbor application. And this will become important as we walk through the diagram here. And you'll understand why soon. So in Compassion, our internal business partners, our external partners, our frontline church partners, our national offices, they're all neighbors to us. And so in this case, we have a specific neighbor and a specific application. So that's where we start from. So in this case, it might be our website. Somebody has come in, they've gone and signed up to sponsor children. They've given us their address in order to support their billing information. So we have an address. So what do we do now? Well, in our case, we decided to centralize around Amazon's EventBridge. So in this case, the neighbor application sends an event to EventBridge. As part of that event, we have the address information. We also have what neighbor and what application sent that particular request to EventBridge. Now, behind EventBridge, when that event comes in, the very first thing it does is it will go and take that event and push it into Amazon Data Firehose, which then stores it out into an S3 bucket that stores all of our incoming requests. This allows us to go back and do analytics over the type of request, how often the request comes in. We can do all kinds of pattern analysis on those requests right there. But to Jeff's point earlier, we want to make sure that we allow access to that data in a controlled manner. And so thus we use Amazon or AWS's lake formation to control the access. So with lake formation, we can control access down to a particular data point within a particular record. Now, once this request has been stored off and stored in our S3 bucket, then the actual processing of that request can come into play. The very first thing EventBridge is going to do is go and fire off what we call our orchestrator step function. So in this case, this is where the neighbor and the application become really, really, really important, because Patch is designed to be a multi-tenant system. And so what we do is we go and we take that neighbor and that application and say, okay, based on those two pieces of criteria, let's go look up what this neighbor and application actually wants to do and wants to do with this address. How do they want to actually check and validate this address? We have a bunch of capabilities for checking addresses. Some of them are more fine-grained than others, and we'll dive into that. But this allows us to say, on a per-client basis, what actions do we really want to have happen? So that first orchestrator step function then goes and loads a secondary step function, which now is able to go through and actually process that request and process that data, and is able to fire off the actual request, fire off the actual checking. Now, behind that, for person screening, we chose to use AWS Lambdas. So that top Lambda there that you see could be what we would call an exact match. So when we do an exact match, like I said earlier, we standardize those addresses as they come in. And as part of that, what we do is we calculate a SHA-256 hash. So now we can take an address and go do a lookup, and it's really, really, really fast. It's just a matter of comparing two hashes. Now, there are cases where, like I said, address data is messy. So what happens if somebody miskeyed an address? They put an extra character in, or it's uppercase, or they put RD and the other record says road. There's all kinds of variations that can happen. And so what we have is other lambdas, like the one at the bottom, that can potentially do things like, okay, are there any known offenders within the zip code for the address that got sent in? And that's just one example. We have currently have approximately 5 different patterns that we look for, and we can use them in any combination. And by using step functions, this allows us to come through and look at all of that along the way. And then behind the lambdas, of course, we're using DynamoDB. That allows us to get single-digit millisecond responses. End to end, this whole system processes addresses typically in less than a second. Our average is actually 600 milliseconds. So end to end, from the time the request comes into EventBridge to the time that it goes out. Now, when that response comes out, back out to go to the neighbor application, on its way out, in EventBridge, we have another rule. And that rule does probably what you would guess, and that is we take the response and we push the response out using Firehose back out to S3 as well. So now we have the incoming request and we have the response. So now we can do all kinds of analytics to say, okay, how many false positives do we have? How many false negatives do we have? We can look at, what's the actual response time that we're getting out of the system. There are all kinds of metrics and all kinds of information that we can derive out of that. And so that gives us a lot of value in having that data. Now, as part of this, it's not called out in the diagram here, but we always have a human in the loop. So even if we think there is an exact match between these things, we always send it to an investigator, because the last thing we want to do is accuse one of our supporters of negative behavior that they didn't commit. So something to keep in mind if you're ever developing systems like this is it's always wise to have a human in the loop in order to validate. But that was just addresses. As compassion has grown, as we've become more digital, as we've tried to expand our capabilities, we've started to look at things like images and video and shorter text, like text messages. So we needed a new approach. So what we did was we went back and looked at, okay, we did all this work for person screening. What can we leverage out of that? And how could we modify that pattern to be able to handle more volume? So in this case, that's what we consider to be content. So it could be pictures that a supporter or a sponsor sends to their child. It could be a picture from a frontline church partner of, hey, here's the children playing at the center. It could be an email message. It could be a letter. We encourage our supporters and our donors to write letters to the children that they sponsor. And so in 2024, we processed over 10 million letters. So how do we go through and look at, we can't physically have people manually looking through 10 million letters a year looking for negative content and looking for something that might have happened. So we had to come up with a different approach. Similar to our person screening, we still leverage lake formation, we still leverage our S3 bucket, but we inserted an additional step into how we process the content side of things. And that is, we put the content into the S3 bucket first. So our neighbor application, the very first thing it will do is it will go through and drop that content into the S3 bucket. Now, one of the things that allows us to do is it allows us to start pre-processing that. So if it's a letter, we may do things like we might go through and lowercase the entire letter. We may take out extra spaces. We may take out punctuation. We may do all kinds of processing on it. If it's a video, we might chunk it up into shorter segments so that it's easier to process and we can do parallel processing over the chunks. So just having it in that S3 bucket allows us to trigger off a lot of different pre-processing that can potentially happen. However, once that data is in that S3 bucket, now we can just pass around the ARN to that object, and we have an easy way to reference that particular object throughout the entire system. And we're not having to move all of that data around along the way as well. Again, leveraging EventBridge. As the request comes in, we still do the same thing here. We go through, we take and use data fire hose. We push that request out to our S3 bucket. We come back and look up our secondary step function. So as part of that secondary step function, again, we've got the neighbor and the application. We can look up that particular step function that says, okay, for this particular neighbor and application, here's how I want you to process this particular piece of content. So that's the third piece that we include in that request for these, is we include the type of content. So now that we know the type of content, let's say in this case, it's a letter that's intended to go from a supporter to a child. In that case, we may leverage Amazon's Comprehend to go through and look at that letter. One of the things that we look for is if you don't have the ability to observe the communications that are going on between a supporter and a child, it's very difficult to monitor what might be going on. And so one of the things that we look for is what we call out-of-channel communications. We ask all of our supporters to, if you write a letter, send it through us. We'll make sure it gets to the child. But that gives us an opportunity to go through and examine that letter and look at the content. And so by leveraging Comprehend, we can go through and look for, okay, are there any links to like a Facebook site? Or, here's my personal email address. And so Comprehend has been great at allowing us to go and look at that. This is the first capability that we're building out. There are a whole set of them. This particular pattern allows us to do things like we can, at the same time that we're looking for out-of-channel communications, we can look for things like profanity. We don't necessarily want swear words getting to the children that are getting sponsored. We can look for grooming language. We can look for any number of potentially negative events or patterns inside of that content along the way. And by using step functions, we can do it all in parallel, we can do it in series. It allows us to have a lot of flexibility in how we approach dealing with the data and how we approach actually looking at it. And so you might wonder, okay, how does comprehend actually get that? Well, to comprehend, we actually pass the ARN of that content that we stored in the S3 bucket. So now comprehend can go pull that content in, it can go do its analysis, produce its results, and then send them back along the way through those step functions back up to EventBridge. And again, following the same pattern, we can take EventBridge, take that response, push it out to our S3 bucket, and now we can do great analytics on, okay, have we set our thresholds too high? Have we set them too low? What is our error rate? It gives us a lot of capabilities to go back and do those analytics. And one of the benefits of this is that there are probably, and I will almost guarantee this, there are analytics that we have not thought of yet. And because of this pattern, we're able to go back and do that because we save that content in that S3 bucket. It doesn't go away. We can go back and say, hey, if we had done this differently, we can go back and run the algorithm, a different algorithm on it, and say, okay, what would have changed? Would we have gotten the same answer? Would we have said, yes, this is good, or no, it's not? We can do all of those and do that prototyping along the way. And this allows us to do things like allow our Ignite weeks to potentially use anonymized data. We can go through and pull all the PII out of this data and make it available for people to look at and use as part of their passion projects or their Ignite weeks and say, okay, let's take a look at this. Let's innovate. Let's leverage AWS and come up with some innovative solutions to help better serve our children and help better serve our mission. And with that, I'll hand it back over to Mike.
Thanks, Alex. Well, if you're like me, I think the kind of things that Compassion is doing is so cool, and I hope you got a sense for some of that today. But your mission likely is not protecting and releasing children from poverty. So how does all of this apply to you? Well, there are a couple of concepts that were talked about today that I think are broadly applicable to most organizations. There are two tools specifically I want to concentrate on, or two themes I want to concentrate on. The first is a data lake, and the second thing I want to talk about is intelligent document processing. And in our discussions today, you heard about how Compassion is moving to become a data-driven organization, and some of you may also be in that process. And if you've tried to work through that, you know that becoming data-driven is extremely hard to do. And why is that exactly? Well, there's a couple of reasons why becoming a data-driven organization is hard. The first, it's hard to find the data, especially as you have lots of AWS accounts spread across multiple regions, as you have a multinational organization. Your data can be spread across lots and lots of places. So finding that data, first of all, is a challenge. And then once you find that data, getting access to that data is hard. Data access control is often error-prone. It often requires specialized tools or specialized policies to grant access. That's time-consuming. It's difficult to keep all of those up to date. This ends up in data analysts and machine learning practitioners not having access to the data that they need. The next problem is getting access to the right tool. Most analysts don't have access to the AWS Management Console. But even if they did, most of the analysis tools don't understand AWS concepts like IAM. And so there's a disconnect there, and it's a challenge to use the tools you need in a way that still protects your data. The next challenge is collaboration. We find oftentimes that analysts, data scientists, data engineers, they all own different stages of that data journey, but they don't have an easy way to collaborate. And then the final challenge is really around data governance. There are constructs in many tools to govern that data, but those constructs are oftentimes hidden within individual tools. They're hard to use, and this prevents you from having 100% traceability across your entire data access pipeline. Okay, so you heard from Alex that they're using lake formation, and lake formation is a tool that can help solve this problem. But how exactly does it solve this problem? Well, it does that in a couple of ways. The first major way that it solves it is that lake formation gives you simplified data access with cross-account data sharing where you don't have to worry about data movement. The next thing that where it really helps out is that it supports delegated governance. And delegated governance means that data producers can grant access to data consumers. Those data consumers can then continue to cascade that access as appropriate. The next way that it helps is through the data access catalog. And the data access catalog makes it easy for data users to discover and understand the kinds of data that they have available to them within the organization and the kind of data that they can use in their analysis and machine learning workloads. And finally, it gives you that data governance piece. It has centralized auditing with CloudTrail audit logs. This makes it easy to monitor and audit your data lake access to make sure that the right people are using the right data in the right way. All right, so let's talk a little bit more about lake formation and how it handles permissions. The big takeaway from lake formation is that it simplifies your data lake permissions by introducing database-style fine-grained permissions. And keep in mind that these permissions apply across the entire data lake stack. So this means that lake formation manages not only the S3 buckets, but the objects in those buckets. It also works with a wide variety of analytics and machine learning engines. So it removes that problem that I talked about earlier of the analysis tool not understanding IAM and other AWS constructs. If you have a large group of users or you need to scale managing permissions, lake formation supports lake formation tag-based access control. This makes it really easy so you can apply a tag to an object and everyone who has permissions to that tag can now get access to that object. And finally, because all access is happening through lake formation, authorization and metadata and access to S3, you can all track all of this through your audit logging to verify compliance with your policies and your procedures. All right, so I'm guessing that most of you have seen one of these two scenarios here, where most organizations we work with are trying to give access to a lot of people their data lake data. And we find that one of two scenarios usually happen if they don't have the right tools and the right permissioning model. On the one hand, data access is so wide that you essentially have to give access to everyone to everything. The other problem we often see is that data access granting is a hard problem. The tools are hard to use, and so people will actively go outside of your data environment and you lose control over who's accessing your data. Again, lake formation solves both of those permissions. Let's talk now briefly, just to kind of wrap things up with lake formation, about that auditing and management piece. So again, I mentioned that lake formation gives you a centralized audit trail where you can track who accessed what data when. You can create alerts and visualize those through the CloudWatch console. And you can then take reporting and move that into your tool of choice, like QuickSight. You can also enrich and expand that data through ETL processes that are available within AWS. Okay, so that's the first use case that I think is broadly applicable to most organizations. The next one I want to talk about is intelligent document processing. And when we talk about intelligent document processing, it's first valuable to talk briefly about the machine learning stack at AWS. When you look at our stack, you can see that we really have 3 layers of that stack. You can think of it as like a 3-layer cake. That bottom layer, the provider layer, you can think of as the DIY layer. This is designed for people that have deep experience with frameworks, with managing infrastructure, and really want to get their hands dirty and just do everything themselves. The layer above that, the tuner layer, is designed for folks that have machine learning experience, but they don't necessarily want to manage the machine learning infrastructure. So at this layer, you oftentimes will use Amazon SageMaker. You need to understand different machine learning concepts like feature engineering. You oftentimes need to know different machine learning algorithms, but you don't need to manage the physical infrastructure that your models are training or inferencing on. And then finally, there's that top layer, that consumer layer, and that's really where I want to spend some time here talking about this. This consumer layer, you can think of it as pre-built machine learning services where you don't have to manage the infrastructure, and in most cases, you don't even need to think about there being a model. You provide data in a certain format, you can get data out in a certain format. And what we usually recommend is that if you have a machine learning problem that typically falls in one of the areas that we have listed here, this is a good place to start. And you can notice under the text section, well, under core, there's that text section, you can see Amazon Comprehend listed. So this is one of our pre-built machine learning services that take a lot of that heavy lifting away from you. And Amazon Comprehend contains some pre-built machine learning models that can automatically identify things like people, places, brands, events. It can determine the language of the text. It can understand the sentiment, whether that's positive, negative, or neutral. It can automatically organize your documents into a collection of text files by topic. But likely you have your own taxonomies. You likely have your own things that are very specific to your organization. And so you can train Amazon Comprehend with a custom model that's specific to you and your organization. You can extract your specific entities that are in your documents. You can organize your data by your specific taxonomies. So we see that Amazon Comprehend is really useful for things like intelligent document processing, automating workflows, support ticket routing, sentiment analysis, PII detection and redaction, and a number of things like that. And just to give you an example of Amazon Comprehend in action, I've got some text here from the Compassion website, where it says International Children's Day is celebrated worldwide. In the United States, it's typically celebrated on the second Sunday in June. The tradition started when the Dr. Reverend Charles Leonard, pastor of the Universalist Church of the Redeemer in Chelsea, Massachusetts, held a special service focused on children. And you can see that Amazon Comprehend automatically identified entities like International Children's Day. It identified locations, United States and Chelsea, Massachusetts. It identified the date, people, organization. It can identify quantity, title, commercial items, events, and many, many other things. And so this is usually the building block, a good first step in building an intelligent document processing pipeline. All right, so we've talked about a lot of things today. As a next step, I'd really recommend you scan the QR code on the left side there. From there, you can learn more about Compassion International. You can sponsor a child. You can support Compassion in many of the other initiatives that they support. If you want to get started with building your own data lake, you can scan that QR code in the middle. And if you want to get started with intelligent document processing with Amazon Comprehend, you can scan that QR code on the right. So with that, we thank you for your time. We'd ask that you complete the survey in the app. And we have a little bit of time, and if anyone has any questions, we could have Jeff and Alex come back on stage and let you ask any questions about them. All right, thank you all for coming.